For D, we have f on the outside and g on the inside. So I'm going to start with my f function, which is 4x squared minus 3x. So I'm going to write this in this way. So 4, I'm going to do x squared minus 3x. So notice I'm putting brackets in so I can group them properly. So inside where the x is, I'm going to put in the g function. So the g goes on the inside. So I end up with 4x squared plus 5 on the inside, 4x squared plus 5 on the inside here. So I've embedded the g into the f function, okay? Again, make sure you notice I'm not multiplying these things together. I'm embedding the blue inside the red. So once I've done that, I just need to rearrange this. So I end up with 4. Squaring that, I get 16x4 plus 4 times 5 is 20x squared, but I have two of them, so 40x squared plus 25 minus 12x squared minus 15. Again, watch the brackets. Okay, so then simplifying this out, I'm going to end up with 64 x to the power 4 plus 160 x squared plus 100 minus 12x squared minus 15. Combining the like terms, I'm going to end up with, this works out to be 148 x squared plus 85 when I combine the like terms. So those combined to give me that, and these combined to give me that. For E, again, I'm going to have the outside function is g. So g is my 4x squared plus 5. So I'm going to write it this way. 4x squared plus 5 minus, I've got an extra coefficient on the outside. That 2 is on the outside of g. So then I need to group the g. So I'm going to put square brackets here. And this is going to be 4x squared plus 5. Okay, so I have to make sure I know the inside parts, the outside parts, and make sure I group them accordingly. So I still have the embedded function f to put inside. So I'm going to end up putting in the 4x squared minus 3x inside the g function, the first g function. And now I've done my function, my combined functions here, or my composite function. So at this point, I just have to simplify this expression. So I end up with 4 16x4 minus 12x cubed twice, so 24x cubed plus 9x squared. We already kind of worked this out somewhere, if I recall. So that's going to be that plus 5 minus 8x squared minus 10. Combining like terms, I get 64 x to the power 4 minus 96x cubed. I'm going to combine my like terms in this step. So I get 36x squared minus 8. That's going to give me plus 28x squared. And then combining the like terms, plus 5 and minus 10 gives me the minus 5. For this last one here, if we're going to do g of the inverse of g of x, well, the inverse of g of x, if I'm going to plug that in, the inverse of g of x, if I were to work this out, it would be this. It would end up with x equals 4y squared minus 5, and then x minus 5 divided by 4, and then it's going to be square root, and that's going to be my inverse of g of x. Okay, and I can plug that in and work it all out. Okay, so if I do, g is going to be 4x squared plus 5, and I'm going to substitute in there x minus 5 over 4 square root. Okay, well, if you notice what happens here, we're going to end up with x minus 5 over 4. Okay, and this is going to be plus or minus 5. Yeah, so I'm going to end up with, in this case, or plus 5. These cancel out, and I end up with minus 5 plus 5, and I end up back with just x. Now, this is a weird result if we kind of do all these steps. However, if we think of this from a different perspective, the g goes one way through a function, and the inverse goes the other way. G is x to y, inverse is y to x. And if we were to apply the inverse, start with y and get x, and go backwards, we always end up with where we started. So for example, if I start with 9, I go that way for g inverse, and this way for g, I end up back where I started. So whatever my input is going to end up being my output whenever I do the embedded the inverse with the original function. So here my input was x, so I'm going to just end up with whatever I started with. And in fact, this can always be generalized by applying an inverse and the function together. We always end up with whatever we started with. In this case, it's going to be x. If I started with A, I would end up with A. If I started with 5, I'd end up with 5. Whatever we start with, we end with, because of the nature of inverse and the original function. Okay, so this is going to be equal to x. And again, if we just map this out, yeah, whatever we start with, if I go backwards and forwards, I'm going to end up wherever I started. And at this point, it would be good to now identify this as an identity. So anytime we see this, we should think that this is an identity, and we can just make this equal to x.